Hey, in this video I'm going to talk about Microsoft Fabric Materialized Lake Views. So what is a Materialized Lake View, or MLV, because Materialized Lake View is a difficult word to say for me, so I will be referring to them as MLVs from now on. In a Microsoft Fabric Lakehouse, you can store files and you can store delta tables. And delta tables are obviously tabular data storage formats. They use Parquet files and the delta lake metadata information, a delta log, etc. And basically they store data column by column in a fixed format. So they are physical storage of tabular data on your data lake. Now, for those of you that have been working with SQL Server databases, you might notice that tables and delta tables are maybe the same thing. Technically, they are not, but they physically store tabular data on disk or on a data lake. In SQL Server, you can create views, and a view is basically a window through which you look at your tables in your database, right? You define a select query, an SQL query that you will write and store as a view, and the result of that query is then being presented to you as if it were a table. However, when you query the view, the underlying query statement will be executed first, so no data is actually physically stored in that view, unless you're working with materialized views in a SQL Server database, which is a whole other topic that we will not be touching today. Now, views give you a lot of flexibility. You can define queries where you will narrow down the number of columns, or where you will pre-filter your query results using where statements. Maybe you can do group bys to aggregate data. And all of that can then be referenced in client applications, like in SQL Server Management Studio or other applications that use tabular data from databases such as Power BI, where you can reuse that stored logic, which is awesome, right? You don't have to do the same queries over and over again. Looking at Microsoft Fabric, you might want to be using the same flexibility, right, that you have in SQL Server Views. And within Fabric, we have something that is called Materialized Lake Views, or MLVs, and they will do approximately the same. They're not really the same as a SQL Server view, but they behave in a very similar way. So today we're going to look at how we can use MLVs in Microsoft Fabric Lakehouses, what they do, what they can do, and also what they cannot do. And I will do a very concrete, pragmatic demo of how we can create, read, write, etc. with all these views. All right, so let's head over to my laptop. And what we're looking at here is a notebook in which I've prepared a few code snippets in order to demo you the Materialized Lake Views, or MLVs, in Microsoft Fabric. Now, mind you, before we start creating MLVs in Fabric, we do need a schema-enabled lakehouse. So if you have a regular lakehouse before we add schemas, that will not work. You will have to create a new lakehouse with schemas enabled. Now, mind you, when I'm recording this video in July 2025, schemas are still in preview. And that means that, yes, you could use them in production, but they might not work as expected. There might be bugs or any other issues with them. So buyer beware, be careful with them. But in order to do MLVs, you do need to have a schema-enabled lakehouse. So before we start looking at the code and writing MLV statements, we will actually first create our schema-enabled lakehouse. We go to our workspace, I click on New Item, and because I'm lazy, I already favorited the Create Lakehouse button right here. If you've not done that, you can go to All Items and you can start searching for Lakehouse right here. Find Lakehouse, and when you click that, you can say Schema Enabled Lakehouse, or give it any other name that you will understand and that will work with your naming conventions, right? It's very important that you check this button, this checkbox for Lakehouse schemas. It is in public preview, as I mentioned, but it will work, and it is quite stable lately. So we click Create, and then the Lakehouse will be created in our workspace. And actually, Microsoft Fabric will now open our Lakehouse. That's not something I wanted to do. Anyway, we can close this and go to our workspace, our notebook right here. Now, as you can see, I have a lakehouse connected to this to this notebook that is called Silver. Why? I once demoed a Medallion architecture setup with bronze, silver, and gold lakehouses. So this is one of the remnants there. And if we start looking at the tables that are here, we will find that we have New York City taxi data in here. And today I will do the demo for MLVs using the taxi zone lookup table, because it's a fairly small table, so we can easily copy over the data and start creating stuff with that. All right, so how does this table look like? Let's run a Spark query here. Select star from silver.dbo.silver taxi zone lookup. This should not take too long. And as you can see here, this is a Python example creating a Spark data frame using the Spark.SQL method in order to actually get data in here. And we do get an error. Why do we get the error? We use three-part naming conventions right here, and that is not allowed in a lakehouse that is not schema enabled. So removing DBO should actually work. I've put this on purpose in this demo because I want to show you that once we start connecting our notebook to the schema-enabled lakehouse, and even in a non-schema-enabled lakehouse, we have to use the three-part naming conventions. All right, so when the query executed, we can see that we actually have a very nice little table here. It's almost 300 records. It's a very small table. It contains the boroughs and zones, etc., within the New York City taxi dataset. All right, now before we can start working with MLVs on this dataset, I have to copy this table over to my schema-enabled lakehouse, because remember, we need schemas in order to work with MLVs. And I will add an existing data source. That existing data source will be the schema-enabled lakehouse that we have right here in my Fabric guy location. When we click on connect, it will automatically connect there. And because I like setting a default lakehouse to the stuff that I want to do here. Now the session has stopped, so we need to start a new session. And now hopefully this will be a little bit quicker. Okay, and the session is now restarted in about 1 minute and 9 seconds. And right now we have a notebook session that is connected to my default schema-enabled lakehouse, but still has access to the Silver lakehouse. However, now what I want to show you is when you've now connected to a schema-enabled lakehouse, even if you write a query on another lakehouse that is not schema-enabled, we actually do need to put DBO as a schema in there, and we do need the three-part naming in order to read data from our Silver lakehouse in this case. As you can see, we got an error here, and the error is saying that silver.silver taxi zone lookup cannot be found. When we put DBO in between here and execute the cell, we should be able to find that the query now can actually be executed. Give it a few seconds, and there we are. So you see that if you have a non-schema enabled lakehouse as the default, you do not do the three-part naming. When you do have a schema enabled lakehouse as the default lakehouse in your notebook, you will need to query every lakehouse in your notebook as if it was a three-part naming convention. Even if there's no schemas, you will put DBO as a schema. All right, so now we have a Spark data frame called df containing the contents of the taxi zone lookup table from my old lakehouse, and we're going to copy that over to the new lakehouse, right? We're going to do that by saying df.write format delta, and we overwrite that into the table's raw taxi zone lookup. And now as I'm saying this, the schema raw doesn't exist. So first let's use the SQL magic command here, and let's create the schema raw. And then we actually have a schema here. Let's refresh. We now have the raw schema, and we can then copy that data into our new lakehouse. This should take just a couple of seconds. It's a very small table. Now if you open this, there's nothing. If we refresh, there is now our taxi zone lookup, and we can now we can validate that the data is actually there in our new lakehouse by running a query against the schema-enabled lakehouse. And within a couple of seconds, probably, we will find that indeed we now have these records here. All right. So now when we start working with the Materialized Lake View or MLV, we do need to write Spark SQL in order to create an MLV. You cannot use Python. You can only use Spark SQL to create MLVs. That's important to know. I think Microsoft are working on a way to use Python to declare MLVs as well. But as of today, July 2025, this is not the case. All right. So when we want to create an MLV, we have to write a SQL statement, and I'd like to use the percentage SQL magic command here in order to write SQL. Now let's create the materialized lake view by simply saying create materialized lake view view.countByBorrow, and if we execute this, it will create the view, but there is no schema view, so we will create schema view first. And now when we do this, and as you can see, it's very important to have your stuff in order, right, before you do the demo. And as you can see, the count by borrow has now been created. The result that we see on the screen is not the output of the view, right? It is the metadata of the view that we see here. We see the namespace, which is the lakehouse name, and we see some other metadata information, right? When it was created, the refresh policy, and so on. All right, we can now refresh our lakehouse connection here, and under tables, not views, but under tables, we will find the view schema and then count by borrow view or table. Maybe I should say table because the MLV is actually a table in our lakehouse. All right, let's see if we can query this count by borrow view or materialized lake view or table. And yes, we can. So what we see right now is that we have 8 different boroughs with a row count. So there's 265 rows in total in this table, I think. And they are divided between Queens and Brooklyn and so on in the following way, as we can see right here. Okay. Now, in a SQL Server database, a view is instant, right? Because you're not actually writing data into the view, or you're not updating data in the view or deleting data from the view. You're simply executing a select query on top of one or multiple tables if you access a view. With MLVs in a Fabric Lakehouse, that is not entirely the case. And I want to demo that by starting to insert data into my table and then checking what happens in the view. All right, so let's insert a record for the Netherlands, where I live, into my view. And now, before we check the view, let's check now the table. We say select star from raw.taxi zone lookup. And indeed, we get, when we scroll all the way to the bottom, we get now this 266th line that is saying the Netherlands, Utrecht, and Woudenberg, which is the little town that I live in. All right. The table has been updated. That's clear. We have proven that here, right? Let's execute our view. Select star from view. But there's no 9th borough now in our view. Why? The materialized lake view in Fabric Lakehouse is actually a table that is being refreshed based on the definition of the SQL, the Spark SQL statement that you've created the MLV with. And that refreshment is going on a schedule. So probably every hour, maybe every day, whatever you define, is the schedule in which the views gets updated. But on your lakehouse, the view is actually a table that physically contains data, right? So the plus side is you don't have to process them. That can happen automatically. The downside is they are not instant like like views are within SQL Server. Now, in a minute after the demo here in the notebook, I will show you how you can actually work with your MLVs and how you can set the refresh schedule and so on. But you can also manually refresh the view, and that is what I'm going to do right now so that we can actually demo that the view is doing what it is expected to do. All right, so we will hit another cell. We will execute a Spark SQL command saying refresh materialized lake view. And then the name of the view, of course. When we do so, the view is being processed. And this is being done as a full process. That means that all the data is being deleted, the query is being executed, and every bit of data is then being pushed into that MLV, right? So now the output of our query is not the output of the view, but the metadata output again. And now if we select from our view, you will find that there's actually a 9th borough in the data set called the Netherlands, which is of course not a borough in New York City, but it proves that the system that we've just set up works. All right. So there is now this new data in the Netherlands. We now know how to create views or MLVs in a Microsoft Fabric Lakehouse. We can also on demand refresh them, and then we can load data from them, okay? I've not created any tables that I've been copying or loading data into using aggregations. However, I created a view with the aggregations, and then when you hit the refresh button on the view or when the refresh schedule runs, your aggregations are being processed. And that also works with joins and with filtering and with column selections and so on. Everything that you could do with views in SQL Server, you could also do with MLVs here in a Fabric Lakehouse, basically. All right. Now, what if we want to change the schedule in which the views are being processed? What we will do is we will go to our lakehouse, and let's find the schema-enabled lakehouse here. Here we are. And then here is a button saying Manage Materialized Lake Views Preview. It is still a preview functionality. We click there, and the lineage view is being opened right here. And I like that it zooms in, because sometimes when it's all the way zoomed out, the letters are very small. So this is actually a very nice overview. And the lineage view here basically means you have some materialized lake view or multiple views, and then you will see where that data is actually coming from. Now, this view is reading from only one table, one delta table in my lakehouse, but it could potentially be that I'm reading from multiple tables that I'm either joining together or stacking together with union statements or anything like that. All right. So in this case, it is only one-to-one, but it could be many tables to one view or many tables to many views or any combination that you could think of. If we want to configure the schedule in which the views in our lakehouse are being processed, we click on schedule. And then here on the right hand side of the screen, we will find that the schedule is off. We will enable the schedule by putting it on, saying it should be repeated by the minute or hourly, daily, weekly, or monthly. Maybe hourly is fine for me, and it should occur every 1 hour at 17 minutes past the hour. That's fine. That sounds cool. And we have a start date time of today. July 31, and the end date time July 31. That's actually not really smart to do, so let's put that to I don't know, somewhere in the future. And there we are. It did not accept that. To somewhere in the future. There we are. We are not in Minsk. I don't know why it says we are in Minsk. We are definitely not. We are in the Amsterdam time zone. We click apply. And now a schedule set that every hour, at 17 minutes past the hour, all of the views in this lakehouse are being processed, are being updated with the latest data. Now, mind you, because you are throwing away the data, executing the view definition, and then loading the data again, you will use up some of your Fabric capacity compute power, meaning that if you have very complicated SQL statements in very large tables, and you're doing this very often on a high-frequency schedule, you will eat up your capacity quite fast, right? There is no support for incremental refreshes at the moment. However, I think what Fabric is doing is that when the underlying data is not being changed, the view will not process because there's nothing to process. So that is a bit of intelligence that has been added to the MLVs right there. But mind you, there's no incremental refresh policies. And loading the views will take some compute power, of course. So be wary of that, and keep an eye out on your Fabric capacity. So now you know what a Fabric Lakehouse Materialized Lake View is. Hopefully you found this video interesting and you learned something today. If you want, you could subscribe to my channel, you could like this video, and if you put a comment, we can get in touch. So if you have any additional questions, leave a comment here on YouTube. I will read them all, and we could be in touch, and see you next time.